Alright, so welcome to the first part of this series where I'm going to be building a nuclear fusion reactor. So essentially this is going to be a project for college and something that I can reference in my paper that I'm writing about this, but this also doubles as content for you guys. So let's get right into it. What do you need? You need a core for the fusion to take place in. You need a power system. Reason that's so generalized is because there's a lot of things that go into that. You need a vacuum system, and you need your fuel system, which is deuterium gas. With the core, it should be vacuum ready. It should be easily modifiable. You should be able to attach certain components on, and you should be able to ground it so you don't kill yourself. The power system has a lot involved in it, so I'll go through it really quickly. You got a transformer, which most cheap transformers don't get above 10 kilovolts, so you'll likely need a voltage multiplier. But before you connect those two to the reactor, you need a variac to your wall to ensure you don't burn your house down. And then the voltage multiplier, which is a circuit of diodes and capacitors that is wound, or it's like a web sort of deal, and that connects. The power output from there connects to a high voltage feed through, which I'm going to be making on my own. Everything that I make on my own is going to be a separate video on how I did so, and so you guys will get that. So that feeds the power into the reactor. The high voltage feed through connects to what's called a fusion grid, and that's usually tungsten or stainless steel wire. You can get it from a TIG welder. That's where the plasma is going to grow. So then you got your vacuum system. That's essentially just a pump and a vacuum gauge. As far as plasma goes, you only need around, I believe it's 10 to 50 microns is a good plasma. But for fusion, you need below 5 microns. So how my system is going to work is that we're going to achieve plasma first, and then we're going to buy a secondary, what's called a diffusion pump, and that's going to do all the work, get us below 1 millitorr, which is very, 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 very low vacuum. So there should be nothing inside there. And then for the gas, so we will use a PIM cell to electrolyze heavy water, deuterium oxide. And by the way, deuterium is a isotope of hydrogen. And we will extract the deuterium gas and we will inject it into the reactor. And from my research, the pressure should be about 10 to 40 millitorr with the deuterium gas inside. So base vacuum should be, we're gonna try to go below 1 millitorr, and then with the deuterium gas inside, it's going to be 10 to 40 millitorr roughly. So that's essentially what you need. Obviously it's a very dangerous process, but how does this even look? Well, I've got two different designs. One is my original design, and then the second one is going to be the one that I'm currently going to this is the current design. This is what I'm going to use. Alright, so as you can see, for the original design, I was going to choose a sphere. Now this would be an 8-inch sphere, and all ports would have been KF25, and they would have been custom. And all ports would have been KF25, and they would have been custom fit into the sphere itself. And we would use 2 hemispheres. That way, it would make it easier to clean and easier to assemble and drill holes and such. However, this design is much more complicated than it needs to be. As you can see, it requires a entirely custom setup. So this adds so many different variables and so many different things that can go wrong. And as you can see with the viewport, this would actually be a custom-made viewport as well. While I am going to try to custom make a viewport for mine, it's not going to be as complicated as my design for this one. So as you can see, most of the stuff is pretty much the same. You can see you got your deuterium supply, secondary valve. This is just to open the main flow, and then you got the needle valve or the bleed through valve, and this is to directly inject the deuterium. However, this design may be, I don't know how this would work, because I'm not an expert in fusion, but I would be concerned that the vacuum would pull the deuterium in instead of letting it get out. So with that, obviously there's some flaws. So on to the next design. And with this, you can see there is a lot better of a design. It's a lot more modular, a lot easier to add stuff onto, and the big plus is that this entire fusion core right here comes pre-made, so I don't have to fabricate or get anyone to fabricate anything. So obviously we got pretty much the exact same stuff. I added the fact that the transformer will be housed in a PVC or wood housing because it is center grounded, so it needs to be up in the air to prevent arcing. And obviously we've got the voltage multiplier. It'll be 4 times, and it'll be submerged in mineral oil. We're thinking about doing epoxy, but that also adds another variable that could fail. So pretty much the entire thing's the same in the core parts of it, but obviously, you know, we've changed up how some stuff is. The deuterium is obviously off to the side here, and I think I'm gonna switch it so they're on opposite sides, which would allow a direct flow of deuterium across the fusion grid instead of it going, you know, from the fusion grid and then down, or even worse, you know, flowing, hitting this corner, and then just going straight into the vacuum. So that would not be good. But obviously you can see this is a much better design. This is just a rough draft type deal. This is not how it's actually going to look. But this just gives us a basic idea of how my fusion reactor is going to look.